Hi, this is Beverly Craig. I'm a board member at Green Newton, resident of Newton for 13 years, and I'm also a LEED accredited professional with the building design and construction specialty. So today we're just going to do a quick webinar for policymakers about green building principles. So just the real basics that you need to know. We can always follow up and answer questions in more detail if you have all those. But this is just sort of a broad overview. So we will be beginning sort of with a quick definition of a term that maybe you've only started hearing about recently, which is passive house certification, and then talk about Green Newton's, three of Green Newton's green building principles that we think are critical for buildings. So in terms of passive house, we have a little quick quiz, which is, can you tell which of these buildings is certified as a passive house building? So this is a retrofit in New York, in Brooklyn, and what you're seeing is actually a thermal image, an infrared image that is showing the heat that is escaping during the winter from various buildings. So red would be the most heat escaping, yellow a little less, and blue obviously the least. So obviously it was that middle building, and that was a retrofit, retrofitted to passive house standards. And when you look at it from the outside, you can see it doesn't really look that different. And that's because most of this is about reducing air infiltration and adding insulation. It doesn't necessarily mean the building looks that different. So what quickly is passive house? When people use that term, what do they mean? So this is actually a German building standard. It started actually in the US in the during the oil crisis, but as energy prices got more expensive here, it sort of transferred over to Europe. And the Germans in particular have been very active in the last 30 years, building homes that are certified passive house. And so there's a number of different characteristics that are really important to passive house construction. One is an uninterrupted building envelope. So that means a lot of times when buildings are built, there might be a porch or something else that might conduct heat from the inside to the outside of the building. And so passive house construction really emphasizes trying to have thermal breaks so that that does not happen. It also requires air tightness that is much, much tighter than you'll see in other construction. So compared to Massachusetts stretch code, we're talking about 5 to 6 times more airtight than you'd be required to build for new construction in Massachusetts. There's also the idea of optimizing solar gain. So when it is possible to change orientation of buildings, you try and do that to capture sunlight during the winter to help with heating. If you're more constrained with where you can site, you look into shading options, both with the building structure itself and possible window treatments or awnings. Because you're tightening up these buildings so much, it's critical that you bring in natural air. And it's part of the standard actually that for multifamily buildings that you bring fresh air to every single bedroom. To lower the energy impact of bringing in that fresh air, you use heat recovery. So you may be familiar with energy recovery ventilators or heat recovery ventilators. The concept there is that the hot air that you're exhausting in the winter, instead of just releasing that, you use a heat exchanger to capture about 80% of that energy and preheat the cool, fresh air that you're bringing into the building. And that means that you have to heat it up less. There's also an emphasis on durable construction details. So a huge amount of emphasis on looking at the air barrier and vapor barrier. And what that means is it leads to wall assemblies that are much less, much more durable and less likely to have rotted sheathing, mold in the insulation. So it makes for a better building envelope. And there's the concept of resiliency. So in the winter, should the power go out, which we are expecting to happen more in the future with climate change, these buildings hold their heat for quite a long time, which means for 4 or 5 days, people will be perfectly fine to shelter in place without having to be relocated. So the overall concept of passive house is really to drive down the heating and cooling loads dramatically. So the goal is a 90% reduction in heating and cooling. So actually that's only a piece of the energy use of a building, right? Some of it is going to be electric plug loads, TVs, refrigerators, things like that. And so a code built building versus a passive house is not going to be that different for plug loads. Similar with lighting, there might be slight benefits with passive house. And hot water is going to be a little bit better for passive house, but we're really focusing on the heating and cooling system and driving those down. So when we look at the overall building, compared to energy stretch code, what you're looking at is probably, when we see built projects, at least a 40% increase in the overall energy use. So if you would require passive house certification for a building compared to like a LEED or energy stretch code, you are looking at least a 40% reduction in overall energy use. So there are a number of other benefits related to passive house: really low energy compared to code, as we just mentioned, improved indoor air quality. So there's filtration, a lot more fresh air. People love these buildings. You'll hear a lot of New York finance agencies saying that they've really found that tenants who live in these buildings don't want to move out, and it means for less turnover, which can be more profitable for an owner. We mentioned the durability of construction. They're also quiet. That's one of the reasons people like these. You aren't going to be hearing your neighbor or mechanical systems going on and off, because they're much more compartmentalized, much more insulation. And I mentioned the shelter in place concept. So Green Newton has a number of different principles, green building principles, that we think are critical in new construction and even in retrofits, but especially in the new construction. And one of the things we want to emphasize is, the difference between LEED, which I'm sure most of you have heard of as a green building principle or green building standard, and passive house. So I'm actually a LEED accredited professional. I think LEED is a fantastic thing, and it's gotten so much market penetration. It's really moved us pretty far in green buildings, especially in the office space market. But it's important for you to realize that only 30% of the points related to LEED are energy related. And what that means is there's a lot of points related to density and access to transportation and whether the site used to be contaminated or not. Stormwater requirements, which Newton's going to require fairly stringent anyway. Green materials, bike racks. It's a lot of great things, but it's not that focused on energy. And when we look at the performance of LEED buildings, especially, like a silver, gold level, or certifiable level, when we look at those built projects in Massachusetts over the last 10 years, they're really not performing better than energy stretch code. So the idea here is that if the state is going to hit our 2050 greenhouse gas goals, we really need all the new construction to be extremely efficient from here out. I mean, we also have to deal with existing buildings, and that's a much bigger issue, but for new construction, the incremental cost is very small, and we can get to much higher levels of efficiency. So that's why we think that passive house is really the critical standard to push from here out for all new construction. The other thing I want to emphasize is passive house has a lot more verification, especially during the construction process, compared to LEED buildings and just energy stretch code buildings. So energy stretch code and LEED are going to require an energy model, but there's a lot of variation in the performance based on sort of what they're planning and what actually happens. So a lot of buildings, compared to their model, are their energy model, we find performance is off by at least 35%. So it can be high, can be low. And it's just that it's not very predictive of the actual performance of a building. With passive house, you're using a much more sophisticated energy model, and all throughout the process, you're running blower doors. So not just at the very end, which would be typical of a code building or a LEED building, but every step of the construction process, you are running a blower door to see that you're going to hit your air infiltration numbers. The second concept that we have at Green Newton for building principles is that we think it's really important that the embodied carbon of the materials that are put into that new construction are considered carefully. So right now, I think this is sort of a new concept that people hadn't been thinking about in the last 10 years as we've been working towards green buildings. But the amount of carbon it takes to have certain materials to build these can be extremely high. They can also be pretty carbon neutral. And there's actually a whole generation of products coming onto market now that sequester carbon so that the building itself can be a net positive. But the concept is if you use a lot of foams, a lot of cement, a lot of steel, blowing agents for products that have high greenhouse gas potential, it might be that the embodied carbon of that new construction is so high that even with passive house, with 40% less every year of operating energy, it might take you 10 or 15 years to work off that initial embodied carbon that you're putting into the building. So Green Newton is advocating that we ask developers to really calculate the embodied carbon of what they're using, try and reduce that by at least 10%, and maybe have an iterative process with planning over time to look at alternatives. There's a lot of great architectural tools right now, like with Revit, that give you other options. There always are trade-offs in terms of performance and cost, and so everything shouldn't be required, but we do want people to be much more thoughtful about what they're using. The third concept is that to meet our 2050 greenhouse gas goals in the state, we're going to really need to be moving a lot of heating that we do with oil and gas right now to electrification. So efficient heat pumps, which are used extremely often in Europe, Japan, China, those heat pumps, or you might be familiar with the residential version of this, which are called mini splits. Those use really efficient electricity to heat and cool. And the nice thing about that is electricity can have a very high renewable content, and that renewable content in the state is growing every year. So even sort of projections, especially when offshore wind comes on in a few years, I know projections are that by 2030, just market rate without any additional requirements, we will probably be seeing the electricity grid up to about 60% renewables. So over time, that's going to be much better. And of course, there can be very little carbon impact if we go to all renewables on electricity. Natural gas, I think we've generally, like 10 years ago, we thought of natural gas as pretty clean, and that's because it burns pretty clean actually at the burner. But now that we've gone more to fracking, which does release quite a bit of methane at the fracking process, and we've been learning about how leaky our distribution system is for the gas network. And methane is a much, much higher greenhouse gas impact than carbon dioxide. So when you look at the overall picture of natural gas, it's actually probably in the range of coal for generating, which is not something we want to see in the future. So we're going to need to move a lot of our heating that we have, especially in new construction, but certainly also in existing buildings, away from natural gas to electricity over time. The initial install for new construction, I think you find everybody is interested in heat pumps. It's actually a lower cost than building a separate heating and cooling system. So that's not a really hard thing to require of developers. Hot water is a challenge. So going without any natural gas, especially for a multifamily building right now, there's not really a commercially feasible alternative for a central system. You certainly can have individual unit heat pump water heaters, but for a central system, which is probably what you want for a multifamily building, the technology is not there yet. So we are requesting sort of what City of Cambridge requests, which is new construction have a plan for when that natural gas system dies in 20 years, or they're thinking of replacing. The technology is probably going to be a lot better at that time for electric hot water products. And so we would like developers building now to plan in enough space and enough flexibility that they can adapt to an electric system. So everybody's curious, so what does this mean cost-wise? And multifamily costs, the incremental costs are very small. We're talking 2 to 5% of incremental cost, which is not nothing. There are new mass save incentives that were just announced. This is for larger buildings so far, but they will be following with smaller buildings as well that are at least a $3,000 per unit incentive that can help offset some of that incremental cost. They're also providing some free feasibility study money for every building to go passive house and some money for the energy modeling. So in Pennsylvania, which is probably the place where they are furthest along in the multifamily world, they have 23 multifamily projects. Those have reported a 0 to 2% overall cost, incremental cost. And now that's a little misleading, I think, because low-income housing tax credits, you really can't overrun on those. And people were probably value engineering out things like landscaping or finishes to get to those numbers. But when you do talk to consultants, the 2 to 5% seems very reasonable. The simpler the building is, so the less complex the roof is, the no basements, things like that, and will lead to a lower cost. So they think 2% is very achievable for a simple building. Then there's also strategies like the earlier you start thinking about passive house in the design process, so as early as possible, before schematics even, the lower cost you're going to be able to do it at. There's also something called alternative energy credits. So people who do design buildings that use all heat pumps for heating and cooling would be eligible for those costs. So in addition to the mass save incentives, or those incentives. The other thing we just sort of want to tease out a little bit is that a lot of the buildings we've seen proposed in Newton have talked about having the roofs be solar ready, but they haven't made the jump to actually committing to installing solar. Those aren't the same things, and you should be aware of that. Also, because hot water is probably our biggest challenge with multifamily buildings, we might want to nudge people into thinking about solar hot water, which could reduce those demand loads a lot. You can always buy renewable energy electricity off-site somewhere. Harder for the natural gas to get that out of systems. Generally, financially, PV is like a slam dunk. Solar PV, which is the electric that you generate on site, there's almost always less than a 10-year payback. And even if they don't have the cash up front to install that, there are a lot of ways that you can lease your roof to have somebody else do that and get a lower price on your electricity. The other thing we would like to point out is City of Cambridge. I mentioned that they are requiring developers to have a plan for how to get to net zero by 2050. We think that means also buying renewables for the rest of the electricity that they can't generate on site. We think that's also a critical thing to plan for and to challenge people to do. So we are available anytime to answer questions that you might have about any of this content or other related discussions. There's a lot of people in Green Newton and just in Newton in general that are real experts on green buildings. So we encourage you to reach out if you have questions. And thanks for listening. Bye.